Well, we've been looking at isosceles and equilateral triangles, and now we're going to be looking at finding some missing measures and missing values based upon the theorems of isosceles triangles and its corollaries, equilateral triangles. And so let's look at this triangle that we have here on the right. Okay, so I see that I've got two congruent angles. And let's just identify the parts of this triangle while we're here, even though that's not part of what we're asked to find. But since we got two congruent triangles that right here, this is going to be our base. And this is an isosceles triangle. Because there's no way with this angle measure here at 120 that angle P and angle M could also be 120. That would be 360 degrees, and that's triangle only has 180. And this side here that's marked 11 centimeters is opposite this angle. So this is a leg, and this side here opposite the angle M is also a leg, and this angle that's 120 is the vertex. So I think we got all the parts mentioned here. We got the base. I guess, well, these are P and M are base angles too. So let's go about here finding missing measures. So we're asked to find the measure of angle M. Well, now if angle M and angle P are congruent, and angle N is 120 degrees, then each triangle we know has 180 degrees. And if I subtract the vertex angle measurement, I'm left with 60. And those 60 angles are for the remaining two angles, which are congruent. So I can simply divide them by 2, and that comes to 30. And so the measure then of angle M, which is what it asked me, but this would also be true for angle P, is 30 degrees. Now, we're also then asked to find what is the measure of segment PN right here. Well, it's a leg, and this is an isosceles triangle, and so the two legs are going to be congruent, and if this leg, MN, is 11 centimeters, then the line segment PN also has to be 11 centimeters. All right, that's kind of fun. All right, we'll take a look at another one here in just a momento. All right, well, now we're being asked to algebraically find some missing values. And so let's take a look at our triangle here. We can tell that this is, in fact, an isosceles triangle because this side is congruent to this side. This would actually be our vertex angle. And that would mean that these two angles here and here, which are opposite the two congruent sides, would be congruent angles in an isosceles triangle. So let's focus here on this angle first, where we got this angle here, which we say is equal to 6x plus 8. Well, first we got to try to find what is the measure of the two angles. And we know our vertex angle is 180. So there's 180 degrees in a triangle. If I subtract the vertex angle, then the two base angles are going to total 120. No, 100. What am I doing? 100. And which means then that each of the base angles, when I divide 100 by 2, they're going to be 50 degrees each. So I can set this equation, or this expression, 6x plus 8, degrees equal to 50 and then solve for x. So we got 6x plus 8 equals 50 because we've determined that each base angle is going to have to be 50 degrees if the vertex angle is 80 and it's an isosceles triangle. And let's subtract 8 from both sides, which means now that 6x is equal to 42. And we divide both sides by 6, and so x is going to be equal to 7. Now, what about y? Well, on this leg here, we have an expression 4y minus 2, and on this leg, we got 2y plus 2, but these are congruent sides. We're told that they're congruent sides, and so this is an isosceles triangle. So we could set both of these expressions equal to each other, to one another, I should say, and then solve for y. And that would give us the side length. Well, we can solve for y, and then from there we could actually figure what the side length is of each of these two legs. Although we're not asked to do that, we may go above and beyond. So then I would say here that then 4y minus 2, this leg, is equal to 2y plus 2, which is that leg. And let's see, let's add 2 to both sides, and let's subtract 2y both sides. So we're adding 2, and we're subtracting 2y. So then that would leave us with 4y minus 2y is going to be 2y. Negative 2 plus 2 is just going to be 0. Positive 2y minus 2y is 0, and 2 plus 2 is equal to 4. And now we're going to just divide both sides by 2, and y is equal to 2. So I'm just curious, let's prove if these two legs with those expressions give us the same value. So if I go in here and I say 4 and I substitute 2 for y minus 2, well 4 times 2 is 8 minus 2, then this side length is 6. We don't know what the unit of measurement is, we're not given that, but we just got a value of 6. So let's go over here to this leg, and so we got 2, we're going to substitute in 2 for y plus 2. Well, I'm going to go up. 2 times 2 is 4 plus 2, and 4 plus 2 equals 6, and shazam, both of the legs are 6. They're both congruent, just as we expected they would be, and isn't it just a wonderful, wonderful day? Finding missing measures and missing values, isosceles triangles.